Graph the functions using the slope and y-intercept. All right, so in order to graph the functions, we basically need to identify the slope and the y-intercept first, then plot the y-intercept and use the slope to derive at least one more point. So what we're going to do first then is to draw a little grid system to do the graph on. So for example A, we'll draw like a little rectangular coordinate system here. Let's go ahead and use that to do our graph. So the form y equals mx plus b is called the slope-intercept form because in the formula, the m, the number in front of x in other words, is your slope, and the b is your y-intercept. So that means in our equation, this is our slope, our m term, and this is our y-intercept, and that's our b. So we just need to find -4 on the y-axis in order to determine where the y-intercept is. So -4 is 1, 2, 3, 4. It's actually right here on our drawing. So there's the y-intercept. And then to use the slope to graph from here at least one other point, we basically remember that the slope is defined as rise over run. Remember that? So rise over run means that basically this number 3 is 3 over 1. This means go 3 on the y upwards because it's positive and go 1 over to the right on the x-axis because it's positive. So remember, this is like your y and this is like your x, right? So just kind of associate those with that. Okay, so from there that means we're going to rise 3 steps, so 1, 2, 3 from our y-intercept, and we're going to go over 1 step to the right to do the 1 for the x, right? And that's a point that we can use to plot the rest of the line. It only takes 2 points to plot a line, so we're basically done at that point. There's our line. It goes on and on forever in those general directions, and that's it. All right, let's take a look at example B then. For example B, again, based on the structure of the equation, that y equals mx plus b format, right? This is essentially your slope. So the m here is -1/4, and your y-intercept is simply 2. Positive 2. All right, so if we draw the same sort of rectangular coordinate system we did before, here we're going to plot the positive 2 first, so it'll be 1, 2, in other words right here on our y-axis, and that's our y-intercept b, and from there we can use the slope to derive the remaining point that we need to graph the equation. So we have -1/4 for m, right? So remember that's rise over run, right? So in other words, we will rise -1, or in other words, go down 1 on the y-axis, and we will run to the right 4 because 4 is positive. So we go down 1 on the y-axis, and then we go over 1, 2, 3, 4 on the x-axis. Now that second point can be used to plot the graph. So we connect the lines, and that's it. Of course, you can come up with additional points if you want, but you only need 2 to plot the graph. And so since we have 2, we're done. If you wanted to plot another point though, of course you could do the same thing again from this point. You could drop down 1, right? And then you can go over 1, 2, 3, 4 and put another point here, right? So we get more and more points on this line as many times as we want to do that. All right, let's take a look at the last example, C. So for C, we basically don't have a slope. If you look at the fact that we're missing mx, right? That term is not in this equation, right? We just have a constant equation. We have y is equal to -2. What this graph is the collection of points that have a y-coordinate of -2. So if we go ahead and draw the grid system like we've done before, so we have a rectangular coordinate system there, and then we find -2 on the y-axis, which is our y-intercept for this graph, and we think about all the points that have -2 as their y-coordinate. Notice you could literally create a list here, x, y points, and we want all the points that have -2 as their y-coordinate. So we just have a bunch of points with -2, -2, etc., right? But you could let the x be anything you want. For example, x could be 0, x could be 1, x could be 2, right? So we already plotted the 0, -2. If we did 1, -2, we'd get the point here. If we did 2, -2, we'd get the point here. So the point is all of these points will be on this line where y is equal to -2. So it's a horizontal line. And so that's essentially the graph of equation C. So the slope, remember, is 0 for this one. So in this case, for C, we have m is equal to 0 and b is equal to -2. All right, very good. So we found the slope and the y-intercept for each of the graphs. We graph the equations. Now let's answer these questions down below. It says, are the functions increasing, decreasing, or constant? Let's tackle function A first. function A is increasing. And why do I say it's increasing? Because it's rising as you read the x-axis from left to right, right? So if you look at the x-axis and you move this way visually, right? And you think about what you'd have to do if you were walking along our line, you'd be walking upward, right? So as we move visually from left to right on the x-axis, the graph is going upward. It's traveling upward, or in other words, the y values associated with each x value as you move from left to right are getting larger and larger, right? So in other words, at x equals 0, the y-coordinate is -4, but at x equals 1, the y-coordinate is -1. It's bigger, and so on and so forth. It just keeps going. So the general idea is that as you move to the right on the x-axis, the equation is increasing, or the y values are increasing. So we'd say that for A, we're dealing with an increasing function. All right, so let's look at equation B then. For equation B, the opposite is true, correct? So as we move this way on the x-axis from left to right, we can see that the y values are decreasing, or in other words, the graph seems to be moving downhill if you go in that general direction, right? Imagine if you were walking on the graph, you'd be walking downhill at this point, right? So as you go left to right, you're moving downhill on the graph. You can tell that the graph is decreasing also because its slope is negative, remember? So think of negative as decreasing. So if your slope is negative, your equation is decreasing, or your function has a decreasing graph, right? Likewise, for A, we noticed that the slope was actually +3, so that meant we were increasing, right, as we moved left to right. So positive slope means your function is increasing, a negative slope means your function is decreasing. So for B, we're going to say we are decreasing. All right, the last graph to look at, of course, is C. When you look at C, it's neither decreasing nor increasing, right? As you move left to right on this graph, you're walking on a flat surface, right? It's a horizontal line. So basically, if you're walking along the line from left to right, you wouldn't notice any change in elevation, right? In other words, the y-coordinate is always the same. It's not going up, it's not going down, it's always -2. So when your slope is 0, that tells you that the linear function is constant. So in this case, our graph has a slope of 0, so therefore the graph is constant. And of course that makes sense because, as we said before, the equation is just y is equal to -2, the constant -2.